Hey everyone, welcome to Math 103, Section 2.3, Part 2. Today we're going to be translating some advanced compound expressions and some application problems. So last time we saw some expressions that had either one operation or two operations. Now we're going to do three operations. Here's an example. 7 less than the product of 3 and the total of x and 8. So there's a lot going on in this one. So we need to simplify things down by finding the simple expression. Recall that a simple expression has one operation and two numbers or variables. So down here we've got less than, there's an operation, subtraction. There's product, that's multiplication. So we already have two operations, so we can't start down there. We're going to have to all the way down to the right here. Take a look at the total of x and 8. So here we have one operation, total, which is addition, and then two numbers or variables. So this translates into x plus 8. Now we'll move to the left. Now we want to include this part. So now we're going to translate the product of 3 and x plus 8. We'll just consider that to be one thing. Product is multiplication, so we're going to multiply 3 times x plus 8, and x plus 8 has to go inside parentheses. Finally, we're going to translate 7 less than this thing. Less than is subtraction, so we start with this, and we're going to subtract 7 from it. So that is 3 times x plus 8 minus 7. Use this technique on your turn number 1. All right, the simple expression here is going to be the product of 2 and x. We have one operation, multiplication, and two numbers or variables. So the product of 2 and x is 2x. Next up, we'll move a little bit to the left here. Now we're going to include this operation, the sum. So we're going to do the sum of 2x and 9. So sum is addition, so we're going to add together 2x and 9. 2x plus 9. Finally, now we're going to include this operation product. So we've got the product of 5 and 2x plus 9. So product is multiplication, so we're going to multiply 5 times that thing. And that thing has to go inside parentheses. So 5 times 2x plus 9. Your turn number 2. So we've got a simple expression down here, the product of x and 3. So that's x times 3. Traditionally, we put the number first, so that's 3x. Now we've got another simple expression here, and that is the quotient of 2 and x. Quotient is division. 2 is the first number mentioned, so that goes on top. X is the second, so that goes on the bottom. All right, now what we can do is include this operation over here, the difference. Now we're going to do the difference between this expression and this expression. So now we're going to do the whole thing. Difference is subtraction. And when it says the difference, we just do them in the same order that they're listed. So we'll take this first one, 2 over x, and subtract the second one, 3x. So 2 over x minus 3x. Your turn, number 3. So we've got the sum of x and the quotient and the difference between x and 8 and 4. So this one gets a little tricky down in the end when you get all those ands. But we're going to simplify it by finding the simple expression. So here's our operation, the difference between x and 8. Now once we get to our second number of variable, then we stop. Forget about the and 4. We only want 2 of them. Difference is subtraction. So this is x minus 8. Next up, we're going to include this operation now, the quotient. So we'll start here. The quotient of x minus 8 and 4. Quotient is division. So the first thing mentioned, x minus 8, that goes on top. Second thing mentioned is 4, so that goes on the bottom. X minus 8 divided by 4. And finally, we're going to do the sum of x and that thing. Sum is addition, so we got x plus x minus 8 over 4. And there's the translation. Now this is originally designed to be a group activity, so we're just going to skip the team up. Unless you have something to team up with, then go ahead and do that. We're going to move on to translating application problems. So as a procedure for doing this, we're going to read through these application problems very carefully and identify the unknown quantity. And that's not the one being asked for in the actual question. It's the quantity that comes after the words, the special keywords, in terms of. Then we're going to assign a meaningful variable to that quantity. And it's important to use meaningful variables. If you just use X and Y for everything, as you're reading through it, it can be hard to remember, oh, what did I assign X to? What did I assign Y to? But if you assign a meaningful variable, it tells you, gives you a hint of what that quantity actually is. And the final step, we're going to express the quantity being asked for in the question in terms of the variable from step 1, or from step 2. So in terms of. Expressing a quantity in terms of a variable means to write an expression using only numbers, operations, and that variable. And you can see some examples there. So let's say I wanted to express the variable m in terms of the variable p. You can think of in terms of as being like the equal sign. M in terms of, and then I'm going to have some expression over here with some p's in it. So I might have 3p, or I could have m equals p to the third minus 6p. There can be more than one p, but there can't be any other variables. I couldn't have like m equals 2x, because I'm expressing it only in terms of p. I might have m equals p over 5. So there's some examples of expressing m in terms of p. Now we're going to do this in the context of some application problems. First example, cell phone company sells 2 models of their latest phone. The basic model is always priced $100 less than the premium model. Express the cost of the premium model in terms of the cost of the basic model. So since we're in terms of the basic model, we have to have some variable to represent the cost of the basic model. So I'm going to define B to be cost of the basic model. So I use the meaningful variable B because right away I know B stands for basic. So it's just easier to read that way. Now we know that the basic model is always $100 less than the premium version. So I just want to think this through with some real numbers. So let's say the basic model is $150. If this is $100 less than the premium model, then we have to add $100 to get the premium model. So I'm going to take whatever the basic price is, $150. I'm going to add 100 to it because the premium is always $100 more. And if the basic model is, let's say, 200, I'd go over here and say 200 plus 100 because the premium model will be $100 more, so it's 300. Or maybe 400 for the basic model. So over here I'd have 400 plus 100. So there's a pattern developing here. Whatever the basic model is, we're just going to add 100 to it. So using some real numbers like this can help us to create the expression. Now numbers that change, those are variables. That's the reason we have a variable, because that number could be anything. Now we've already defined the basic model to be B. So I'm just going to call this B. This is a number that changes, and I'm going to represent it with the variable B. Now over here I need an expression for the price of the premium model in terms of the basic model. So that means we can have some B's over here. Well, where's the B going to go? Well, 150 matches up with 150, 200 with 200, 400 with 400. So this changing number here has to be the same B over here, right? Same numbers. Now these numbers over here, or this number's not changing at all. It's a constant. So it's 100, it's always going to be 100. And we always have this operation here. So B plus, bring down the plus, bring down the 100. And there's your expression. The cost of the premium model in terms of the basic model is B plus 100. Now if you can just think it up and write it down, you don't have to go through all this. But if you're having a hard time thinking about what's this expression going to look like, if you start with some real numbers, it can make more sense. Next example, we have a gravel hauler that has 7,000-pound load of gravel. The entire load should be split up and delivered to 2 different locations. Express the amount of gravel delivered to the second location in terms of the amount of gravel delivered to the first location. All right, so we are going to express the amount of gravel delivered to the second location in terms of the first location. So this is the in terms of part, so we need a variable for this part. So I'm just going to call that F. F, gravel to first location. F for first. Easy to remember that way. So now we're starting off with 7,000 pounds. We're going to drop some off here, and then the rest goes over here. So let's say at the first location I dropped off 1,000 pounds. Well, I started with 7,000. I just dropped off 1,000. How much do I have left? When you remove something in math, that's subtraction. So we started with 7,000, and we removed 1,000. So I have 6,000 at the second location. Let's say I dropped off 2,000 at the first location. Then I'm starting with 7,000, dropped off 2,000, so I removed 2,000, subtract 2,000. Or let's say I dropped off 5,000 at the first location. That would be 7,000 minus 5,000. You can come up with any number like that. All right, well, we've defined F to be the gravel at the first location. So that's F. Now over here, the number that's not changing is 7,000. So that stays. And the subtraction, that's not changing, so we're going to keep that. And then this number is changing, so this one's going to be a variable, and it matches this one. So we're going to use the same variable over there, or F. So this expression here, 7,000 minus F, represents the gravel that we drop off at the second location in terms of the gravel we drop off at the first location. Your turn number 4. Let's do part A. Your turn number 4. In part A, in a 2019 Badminton League, the Cougars averaged 2.8 points per game more than the Bears. Express the points per game of the Bears in terms of the points per game of the Cougars. So there's our key phrase, in terms of. And what follows that is the points per game of the Cougars. So there's our variable. I'm going to find that to be C. Now we can do an experiment just like we did in the examples. Then I'm going to try a couple different approaches. Right, so we got the Bears and the Cougars. First I'm going to make up a point total for the Bears and then see what the Cougars then have to score. So let's say the Bears have 10, and we know that the Cougars have 2.8 points per game more than the Bears. So that means if the Bears are at 10, the Cougars are at 10 plus 2.8. And if the Bears get 20, the Cougars would then have to be 2.8 more than that, so 20 plus 2.8. And if the Bears got 30, 30 plus 2.8. Now the number that's changing here is the Bears' score. So we'd have to come up with a new variable in B because we haven't defined that one. And that doesn't match the variable we defined. And over here, since the 10 matches the 10, 20 matches the 20, 30 matches the 30, this variable must be the same as this variable, so that one would be B. And then we'd have plus 2.8. But this can't be it because we've got this new variable and we never use C. And this means we're expressing the point totals of the Cougars in terms of the Bears' score. Well, that's exactly the opposite of what we want. So this one's not going to work. So we're going to need to switch things around. So instead of making up points for the Bears, I'm going to make up points for the Cougars. So let's say the Cougars score 10. Well, that's 2.8 more than the Bears. So that means instead of adding over here, I'm going to subtract on this side. So 10 minus 2.8. Now we still have that 2.8 differential between the Cougars and the Bears. And if the Cougars get 20, then over here we'd have 20 minus 2.8. And if the Cougars get 30, then the Bears would be 30 minus 2.8. All right, so this number is changing. Here's a variable. And it's the number of points the Cougars are scoring, which we have defined to be C. And then this row matches this row, so this must be C as well. Same variables, same numbers. Now this part doesn't change at all. The minus doesn't change. And the 2.8 doesn't change. Those are constant. So those will remain. And then here's our expression then. We're expressing the points for the Bears in terms of points for the Cougars. Part B. The average brain size for a human is 4 times that of the average chimpanzee. Express the average brain size of a chimpanzee in terms of the average brain size of a human. Okay, there's our key phrase, in terms of, and after that is the average brain size of a human. So there's our variable. So I'm going to define that to be H. H is the average brain size of human. All right, so make up some example numbers and see what happens. So we see that the average brain size of a human is 4 times that of a chimp. So if the chimp were 1, the human would be 4 times that. And if the chimp were 2, the human would be 4 times that, which would be 8. And if the chimp were 3, the human would be 4 times that, which is 12. All right, but I don't want changing numbers over here that are different. All right, here I've got the human, average brain size. Numbers are changing. We've defined that to be H. So over here we need something with H in it. So how can I get the H over here? Well, what we did this way was take 1 and multiply it by 4 to get human. So if we want to do the reverse, you have to do the reverse operation. The opposite of multiplication is division. So I'm going to write 1 as 4 divided by 4, and 2 as 8 divided by 4, and 3 as 12 divided by 4. And now we can see how we can create an expression using H. 4 matches 4, 8 matches 8, 12 matches 12. So the numerator is H. Now the divisor line, that never changes, and the denominator never changes. That's always 4. So here we have H divided by 4. So another way of thinking this through is, since we had to multiply chimp size to get the human size, we have to divide the human size by 4 to get the chimp size. Just do that opposite operation. This writing down the numbers is just a way of kind of experimenting and seeing what patterns we come up with. Well, the pattern was we have to divide by 4. Part C. In a recent survey, 1,000 high school graduates were asked whether or not they plan to attend college. Express the number of students who plan to attend college in terms of the number of students who do not plan to attend college. All right, locate the key phrase in terms of. What comes after that? The number of students who do not plan to attend college. So there's our variable. I'm going to define n to be number of students who do not plan to attend college. All right, so here's the attendees. Here's the people who are not going to attend. So we have 1,000 total, which we're going to split up into these two groups. So let's say 100 are not going to attend college. So we removed 100 from the group of 1,000. If you remove something in math, that's subtraction. So the attendees would be 1,000 minus 100. And let's say 300 are not going to attend college. Then it would be 1,000 minus 300. Now let's say 700 are not going to attend college. Then we'd have 1,000 minus 700. All right, here's our changing number. That has to be a variable. We've defined those who are not going to attend college as being n. So that part is n. Now on this side, the 1,000, that's not changing. So that stays 1,000. The subtraction, that's not changing. Here's our changing number, which is n. So 1,000 minus n is the number of people who are going to attend college expressed in terms of the number of people who are not going to attend college. These types of problems can be really challenging because they require taking verbal ability and mathematical ability and putting them together to solve a problem. That's pretty tough. They take a lot of practice. So if it's hard at the beginning for you, if you're struggling, don't give up. Keep practicing. This is one of the most useful skills in math because this is where we actually get to apply it to real-world problems. All right, everybody, that's it for today. Have a great day.